Good morning, children. We are proceeding to the third chapter, Analytical Geometry. The word geometry tells me about diagrams, drawing, something like a square, a rectangle, a line, a point. So we are drawing. The word analytical, or I can say algebraic, represents writing the same in terms of an equation using x, y, z like that. The very first concept we are going to learn about locus. What do you mean by this word locus? Locus is a path traced by a moving point. Suppose a point is here. I am throwing this. So it will go like this. A point may move like this. A point may move like this. So whenever a point moves under fixed conditions, we call it as locus. Very first example, let there be a fixed point. This is a moving point. How does it move? It moves in such a way that the distance from O to P is constant. So as P moves like this, anywhere I measure, the distance is constant. So this locus we call a circle. The next idea, there are 2 points, A and B. A point is moving, let me say P. How does it move? Distance from A and distance from B are equal. This is 10 meters. This is also 10 meters. So P is moving in such a way that every time the distance from A and distance from B are equal. So P moves like this, and this is nothing but a perpendicular bisector of the line joining A and B. So this exercise, we are going to do problems based on locus, where they will give you some conditions. For using in the exercise problems, take the moving point as x, y, and the fixed points 1 or 2 they will give in the question. We need to find the distance. Majority we are dealing with distance. Remember the distance formula, root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Using the distance idea and the conditions given in the problem, let us proceed. Exercise 3.1, question number 1. Find the locus of a point which is equidistant from 1, 3 and x-axis. In all the locus problems, let us consider the moving point to be capital P, which takes the coordinates x, y. Just a moving point we have marked. Distance from 1, 3. So mark 1, 3 and x-axis. From the point P, this I call the distance x and this I call the distance y. X, y. My question is distance from x-axis. So distance from x-axis is nothing but y. Since the coordinates are x, y, distance from y-axis is x and from x-axis, this distance I call y. Distance from 1, 3. The distance formula, root of x minus 1 the whole square plus y minus 3 the whole square. Given the word equidistant. The word equidistant tells me these two distances are equal. Root of x minus 1 the whole square plus y minus 3 the whole square equals to y. Whenever square root is coming, let us square on both the sides. As I am squaring, root and square will get cancelled. I am left with x minus 1 the whole square plus y minus 3 the whole square equals to y square. This is a minus b the whole square expanding x square minus 2x plus 1 a square minus 2ab plus b square. Similarly, this is y square minus 2 into y into 3 plus 3 square which is equal to y square. Cancelling y square and y square, simplifying this answer, x square minus 2x minus 6y 1 plus 9 together it is 10 which is equal to 0 and this is the required locus. It will be better to represent P as x1, y1. So wherever y comes y1 and wherever x comes x1. As I change, in the last line, let us write with xy because a particular point I can take x1, y1 as it is moving. x1, y1 we generalize as xy. So in the last line, wherever x1 is coming, put x and wherever y1 is coming, put y and we get the required locus. Exercise 3.1 question number 2. A point moves so that it is always at a distance of 4 units from the point 3, minus 2. As before, let us take the moving point to be capital P having the coordinates x1, y1. The given point is 3, minus 2. Call it as A. The condition is distance of 4 from the point. So AP, the distance equals to 4. Use the distance formula x1 minus 3 the whole square plus y1 minus of minus 2 is plus 2 the whole square root equals to 4. Whenever we have square root, let us square on both the sides. Root will get eliminated. 4 becomes 16. Expand this a minus b the whole square. A plus b the whole square. A square minus 2ab plus b square. Similarly, a square plus 2ab plus b square. Bring 16 to the left and whenever we are writing, write it in standard form. X first, x square, then y square, then x, y constant. Last line when you write, remove the ones because x1, y1 is a particular point. As it is moving, remove the suffix and write x, y in the last equation which is the required locus. Question number 3. If the distance of the point from the points 2, 1 and 1, 2 are in the ratio 2:1, find the locus. Take the moving point P as x1, y1. The given points, 2 points are given, call them as A and B. Capital A 2, 1 and capital B 1, 2. They are in the ratio 2:1. What does this tell me? PA is to PB equals 2:1. Or I will say PA by PB equals to 2/1. Squaring on both the sides, PA square equals to, cross multiplying, 2 square is 4, PB square. So we have squared, PA square by PB square is 4 or cross multiplying. What is PA square? The distance formula. But since it is square, no need to put square root symbol. Let us substitute x1 minus 2 the whole square, y1 minus 1 the whole square equals to 4 times PB x1 minus 1 the whole square plus y1 minus 2 the whole square. Expanding this, x1 square minus 2 into a into b, 4x1 plus b square is 4. y1 square minus 2 into y1 into 1, 2y1 plus 1, 4 into, again expand this, x1 square minus 2x1 plus 1, expanding this, y1 square minus 4y1 plus 4. There is a 4 here. Multiply every term. 4x1 square, 8x1, 4, 4y1 square, 16y1 plus 16. Here I have x1 square, y1 square, minus 4x1, minus 2y1, 4 plus 1 is 5. Bringing all the terms to the same side and writing in the standard form, I get 4x1 square plus 4y1 square minus 8x1 minus 16y1, 4 plus 16 is 20. Plus x1 square will come to the other side as minus x1 square minus y1 square plus 4x1 plus 2y1 minus 5. I have brought all the terms to the same side equals to 0. And now simplify this. 4x1 square minus x1 square is 3x1 square, 3y1 square minus 4x1 minus 14y1 plus 15 equal to 0. So the required locus is, leave the ones and write the answer. It is 3x square plus 3y square minus 4x minus 14y plus 15 equal to 0. Question number 4. Find the point on x-axis which is equidistant from the points 7, minus 6 and 3, 4. Let the moving point be x1, y1, usual way of taking. But the point is on x-axis. What does it mean? If the point is on x-axis, the y-coordinate must be 0. So we will take x1, 0. The given points, call them as A and B. Given equidistant, that is PA equal to PB. Root of PA. Find the distance formula. X1 minus 7 the whole square plus 0 minus of minus 6 is plus 6 the whole square equals to root of PB. X1 minus 3 the whole square plus 0 minus 4 the whole square. Since root is coming, let us square on the sides. X1 minus 7 the whole square, x1 square minus 2 into x1 into 7, 14x1 plus 7 square. 0 plus 6 is 6, 6 square is 36. The right side, x1 square minus 2 into x1 into 3, 6x1 plus 3 square is 9, 4 square is 16. Let us bring to the same side and simplify the answer. x1 square on both the sides will get cancelled. Bringing the terms to same side. Minus 14x1, 49 plus 36, 85. Minus x1 comes as plus 6x1. 9 plus 16, 25 comes to the left side as minus 25 equal to 0. Minus 14x1 plus 6x1 minus 8x1, 85 minus 25 plus 60 equal to 0, or simplifying this answer, dividing by minus 4. It is 2x1 minus 15 equal to 0. 2x1 equals to 15 or x1 equals 15 by 2. The question is find a point on x-axis. So, the required point on x-axis equals to 15 by 2, comma, y value is 0. So, 15 by 2, comma, 0 is the required answer. Question number 5. If A minus 1, 1, B 2, comma 3, find the locus of P so that the triangle formed by APB has the area 8 square units. Let the moving point PB x1, y1. Given points AB we have written. Given area of triangle APB is 8 square units. How to find the area? Remember the procedure we used to do in standard 10. The point x1, y1, the point minus 1, 1, 2, 3. Again we write x1, y1 equals to 8. Remember the procedure, how we multiply. Diagonally we start like this, x1 into 1 minus 1 into 3, 2 into y1. So we write half into x1 into 1 minus 1 into 3 plus 2 into y1 minus, take the other one, y1 into minus 1, 1 into 2, 3 into x1. y1 into minus 1, 1 into 2, 3 into x1. This is equal to 8. Cross multiplying. x1 minus 3 plus 2y1. Minus into minus plus y1 minus 2 minus 3x1 equals 2 8s are 16. Simplifying the answer, x1 minus 3x1 minus 2x1, 2y1 plus y1, 3y1 minus 5, 16 to the left side, minus 16 equal to 0. Or changing the symbol throughout, 2x1 minus 3y1 plus 21 equal to 0. Or we get the required locus is, leave out the ones and write 2x minus 3y plus 21 equal to 0.